In a previous video, I'll link it down below, I was calculating I actually did two things. I calculated the moment of inertia of a solid sphere, and I calculated the volume of a solid sphere. And in both of those, we use spherical coordinates and the volume element in spherical coordinates. So the volume element, dv, in spherical coordinates is, actually this should be rho, r squared sine theta dr d theta d phi. And I wasn't really happy with this, but what I really wanted was a nice visualization of what this volume element looked like, and that's what we're going to make. So let's just review real quickly. If I want to convert from spherical to Cartesian coordinates, which I need to do because I'm doing this in Python, and Python uses Cartesian coordinates. First of all, I'm going to call this vector, the distance, rho, because I'm going to use r for something else. So if I want to find the x value, it's going to be rho times the sine of theta, and that gives me this component up here projected. Oh, it looks like it's projected down into the xy plane, and then I take cosine phi to find that projection into the x direction. So you got to project twice. For the y component, you project with sine theta into the xy plane, and then sine phi, and then the z component is just cosine theta. And then the volume element is rho squared sine theta dr d theta d phi. So if you want to think about this part of the little box, let's draw the box bigger. These are both curves. It's kind of hard to draw. Okay, so this part is in the rho direction. That's d rho. So it's just d rho. D rho is a length unit. This one right here is, if I move it in the theta direction this way, the length of that arc length is going to be rho d theta. So that's how I get that. Now, the length of this is actually a projection into the xy plane, so it's going to be rho sine theta is the r value, and then then I have d phi. And so if I pull it all together, I get the two rho squared. The sine theta is from the phi direction, and there you go. But I don't really care about that. I want to draw it. So let's jump over here to Python and see if we can make this actually happen. Now, I should have shut my blinds. Should I shut my blinds? Let me shut them real quick. Is that better? Yeah, I think that's better. Okay. So I've already started this, and I made the x, y, z axis, and let's just see what this looks like. And really, this is an art class here, right? We're making art. So I made 3 arrows, and I started them from negative 1 to positive 1 in the x, y, z direction. And I made them different colors. I made them a little thinner, and so we have this. Now, I already noticed, I don't really like when you turn it, it looks a little pale. I need to like turn up the shininess or turn up emissivity or something, but I'm not going to do that right now. Because I want to get it focused on what we're doing. One of the things you'll notice, oops, I didn't want to do that. The cyan is z, right? Python does x is that direction, y is up, and z is out. Okay. So I have my coordinate system. What I want to do is to put a point and move it in the shape of that box and trace out something. I think it'll be fun. Okay. So let's start with a point. So the first thing I want to do, I made these 3 arrow objects, and then I have a rho, a theta, and a phi value. And then what I'm going to need to do is to have, how big do I want in the rho direction, d rho, d theta, d phi. But I'm going to actually have to have 2 of them, because I want a total size. I'm trying to think what to call it. D rho? No. Delta rho. Let's call it delta rho. So delta rho is the distance in the rho direction, and let's call that. Let's put that at, how big do I want my box? If that's at 0.8, let's make it kind of big so you can see it. Let's make it 0.2, and then delta theta. So that's going to be from 0 to 2 pi. Or 100, and this in degrees, it's going to be, theta goes from 0 to 180 degrees. So let's make it 10 degrees. So 10 times pi divided by 180. And let's make delta phi also 10 degrees. 10 times pi divided by 180. And we can change that. Now, I'm going to obviously be calculating R values based on rho, theta, and phi. I'm going to change those. So I want to make a function, and I'm going to call this function R. And that's why I use rho. See, I thought ahead. So I'm going to say def R. I'm going to pass it a rho value, a theta value, and a phi value, and it's going to return a vector, okay, a Cartesian vector. So let's say rho t for temp, theta t for temp, and phi t for tip, or that looks like fit. Well, whatever. So now all I'm going to do is to calculate this temporary vector, rt equals vector. Let's do this. Let's just do it this way. Rho t times, the x value is going to be sine theta t times cosine phi t. The t stands for temp. The y value is going to be rho temp times sine theta temp times sine phi temp. And see, this way I don't have to keep writing this. And then the z component is going to be rho temp times cosine of theta temp. And let's just return that vector. Return RT. So now if I just say something like this, it's really nice. Let's just say print R of 0.8, 0.2, 0.3. That's my theta. Those are all my angles. I can do that. And it should return a vector. Okay, but let's put it, and it did. At least it seems reasonable. Let's use these values up here, and let's make a point there. So I'm going to have my point, then my moving point. It's a sphere. Its position is going to be R of rho theta phi. See, isn't that nice? I say that's its position, R. I like that. Now the size, the radius is going to be 0.02. And color equals color. Let's just leave it as white. But let's do make trail equals true. You'll leave a trail. Okay, so that's going to be my point. Let's see if it puts it there. There's my point. Okay, so now what I'm going to do is to move. I'm going to make a bunch of paths, right? So I'm going to move first in the positive R direction. So let's do this. Now you can't, if you just move the point there, it will draw a line to the new point. But then if you move it to another point, it's not going to draw the intermediate point. So you have to do all of this. You have to do it a little bit differently. You have to use a rate statement. So let's move it in the R direction. So I'm going to say while I have my rho value, while rho, I guess I should say rho, let's say while rho is less than, rho is just a value, rho plus delta rho, right? Then it's going to be as big as my box. I'm going to say rate 100. Now I do need, I'm going to make some more variables. D rho equals 0.01. D theta equals delta theta divided by 100. Let's say this is make this delta rho divided by 100. And so I have 100. I don't need 100. Let's do 50. This is how many steps I'm going to take. D phi equals delta phi divided by 50. So this loop is going to keep going on until rho gets to that value. So I'm going to need to increase rho. So rho equals rho plus d rho. Now see this, I have the delta rho, which is the total size, and d rho is the step size. Now for each step, I need to move the point. So I'm going to say, let's just put it right here, point.pos equals r rho theta phi. So I'm gonna draw the point, I'm gonna update rho, and I'm gonna move the point. And I'm gonna keep doing this. So this should draw a straight line. Let's see if it does indeed work. It's big. Oh, I did something wrong. What did I do wrong? Delta rho is 0.2, while rho is less than Row. Oh, that's why. Because row keeps increasing. So this is row start. Row start. Row start. And then let's put this at point row start. 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 That's fine. And then I'm going to say row equals row start. Theta equals theta start. Phi equals phi start. And then this will be while row is less than that. So that should do it. That should do it. But weird things happen, and I'm not the best at all these kind of things. Okay, it did. There we go. So it's a big box, and that's fine. I want a big box. Next, I want to move in the which direction should we move next? Let's move in the theta direction. So we're just going to increase theta and do it all over again. I'm not going to move my point. I'm going to keep row where it's at. Okay. So I'm going to say while theta, can you see that? No. While theta is less than theta start plus delta theta. Rate 100. And this is actually the same line right here, but not indented. And then update theta. Theta equals theta plus d theta. Let's see if this works. So it should move the first path, then the second path. Nice. Nice. Okay. My theta value is a little, I think I need a smaller r. Let's put this at 0.1. Okay. Now I'm going to go down. I'm going to go back down. So I'm going to do this exact same thing. But I'm going to change it. So I'm going to say while row is greater than row. I want to get back down to row. I need to increase my rate statements because I'm not patient enough for that. Ooh, I did that wrong. Wow. Oh, that's why. Because I need to move this. It has to be minus d row. I'm moving down. And I said I need to increase my rate statements, and I don't. Look at that. Looking nice, huh? Okay. So let's increase these rates to 500, 5 times as fast, because no one wants to wait. No one wants to wait around for that. So now I've gone up in the r direction, in the theta direction, down the r direction. Let's go back in the theta direction, and I'll make a box. So we're going to repeat the same box. So I'm going to do this. Let's copy this whole thing. But now I'm going to say while theta is greater than theta s, just like I did before. And I'm going to say theta minus d theta. But you will know that it is a curved path, and that's nice. There we go. That looks really nice. I'm pretty happy. Okay, now we need to go in the phi direction. So I'm going to go in the phi direction, and then I'm going to repeat this same thing over again. And then I need to connect. I need to do something. Okay, so let's do up and do the phi direction. So I'm going to say I need to go. No, what do I need to do? So I'm back where I started. So I just need to go in the phi direction. So let's just copy this. Let's copy this one. And we're going to say while phi is less than phi start plus delta phi, and that's fine. And then phi equals phi plus, so it's going to be phi equals phi plus d phi. Is this going to work? I hate running this every single time, but okay. See, so, and you know, that is correct, right? Because the phi direction is this way. Remember, that's the z-axis. So now I need to repeat this same thing with my new value of phi. So what I'm going to do, let's see if I can copy this. I think I can just redo this whole thing. Copy all this part right here. Let's see if that works. Just redo it again. I think that should work. Ha! Look at that. Okay, so now I need to get, oops, I can zoom in. So now I need to get 1, 2, I need 3 more paths. So we're right here. I need to move up to that point right there. So that's an increase in the theta direction. So let's just go back in the theta direction again. Let's just redo that, which would be the last time I did theta, increasing in the theta direction. It'd be this. So I can just redo that path. And if you're thinking, that's a lot of dumb code, you could have done this a lot better. I agree, but it's kind of fun. So it's fine. So let's run this one. Okay, so now I'm back to where I want to go. Now I want to go in the positive phi. No, I want to go in the negative phi direction. So let's go in the negative phi direction. So here's my phi. Where is phi? Theta. This one right here. So let's go, let's do the negative one. Do I have a negative phi? There's rho, theta, phi, theta. I never went in the negative phi direction. Okay, that's fine. So we can do that. Down here, down at the end. We got to do these in the right order. So it's going to be, get rid of that. Phi start greater than minus phi. Okay, now I need to go, I'm right there, I need to get up to here, so that's going to be in the positive R direction. So I need to do a positive R move, which I've already done, which would be this right here, right there. A positive rho, okay, I get it. Positive rho direction, oops, I want to put a space. Okay, let's just see. I know it's a lot of work, and it's tedious, but sometimes things just get tedious. Okay. Now I need to go in the positive phi direction. Positive phi. The positive phi direction. So we're down at the bottom. I can just copy a positive phi right here. I mean, copy and paste is your friend. I don't know if you knew that. Okay. Now I need to do 2 more moves. I need to move in the positive theta direction and then the negative phi direction. Let's see if we can do these at the same time. So positive theta direction. Positive theta direction. And then what did I say? Negative phi? I think the negative... No, what did I say? I can't remember. Okay, let's run it. I was going to do 2 at one time. And I was going to be cool. Oh, I didn't. There's something happened. Did it give me an error? I didn't do what I wanted to do. Let's get rid of that last statement because something's wrong. I'm going to just copy this. Oh, I think I need to go in the negative theta direction. Okay, run it one more time. Okay, so I need to go in this direction. So that's the positive theta, right? That's positive theta is this way. No, that's negative theta. That's right. Okay. So I need to do a negative theta right here. And add that down. This is messy, but I only have to do it once, and I'm going to have art forever, right? Copy and paste for a short while. Now I just need to move in the negative phi. I'm pretty sure that's negative phi. So where's a negative phi? Negative phi. Here's negative phi. And I will be done. And I'm going to show you something cool after that. And I will give you the code so you don't have to copy and paste as many times as I copied and pasted. Boom! There's my spherical volume element. Isn't that cool? Okay, so now we can do a whole bunch of things. I could change the size of my deltas. I can make them both all bigger. I don't know why I'd want to do that, but if I want to, it doesn't matter, right? That actually does look even better. There's my spherical volume. Let me get it the way you'd normally see it. Like that. That's pretty cool. Okay. Saving this one for sure. Next time I have to do spherical coordinates. Let's add one more thing. Let's add, let's do this. R arrow equals arrow. Position equals vector 0, 0, 0. Axis equals R of row start, theta start, phi start. And let's leave it white. And let's do, how do you make that thinner? I can't remember. Shaft width. Shaft width equals 0.2. What are those? 0.2. So let's put this one at 0.04. Nice. That's a picture right there. Take a picture. That's a picture. I'm pretty happy. I guess if you wanted to, you could add labels. You could fill it in. I'm not really sure. I originally was going to do like a random points in there, but I didn't. But I'm pretty happy. Oh, is that right? I think that is right. It looks tilted because I'm only moving them in the positive directions, not the negative directions. But that's the way it's defined, so it's cool. Okay, save that. I'll give you a link to that code down below. If you want the link to the derivation of the volume of a sphere, if you want the link to the derivation of the moment of inertia of a sphere, I'll put those two also down below, and that's that.